So we are quite early here in the agenda, but I guess the next speaker is ready. So with that said, I'd like to introduce the next speaker, who is Alex Bortok, who will be presenting Network CI with Open Traffic Generator API. Alex is a product manager at Keysight Technologies, and he traveled from Mountain View, California to join us today. This is Alex's first time presenting at Nanog, and I do believe that Alex is going to have a co-presenter as well. So with that said, welcome to the stage, Alex.
All right, thank you very much, and hello everyone. So yes, I'm going to present a work that Ixia team at Keysight was doing for the last couple of years, which is culminated in an open network community project called Open Traffic Generator API. So this project already gained quite significant traction among a few other open network community projects, and we feel like it's a good time to bring it to the attention of the larger network operator audience to see how we can, how you can extract more value, how we can keep evolving the project based on your needs, along the lines of the network operator continuous integration pipeline. So what I was going to do today is to give you a very brief overview what the traffic generator is and when people typically use it. And then we'll see how we think that the Open Traffic Generator project can expand this usage across multiple use cases. I'll have some information about examples how to use Open Traffic Generator API. And then we're going to dive into one use case we have among, where we have most traction with OpenConfig project. And then we'll explore new opportunities we are looking for in the network operations space. So in general, when we use a traffic generator, what it means is we want to test a network device or maybe a portion of the network. And so what it means is we need to surround this device or network with a set of test ports from which we're going to be sending traffic by, kind of creating a cloud of generated network and all hosts behind those test ports. And so the typical capabilities of the traffic generator that allow to do that is to create frames of, flexible formats with different headers and so on. Be able to schedule traffic flows with needed packet rate, interval between packets, packet sizes, for how long you want to transmit that, and so on. And as part of that, most oftenly, we would also bring some routing, maybe L2 protocols between the test ports and the device under the test, either so that the traffic would flow through the device, or maybe we just want to exercise the control plane itself, inject like 1 million routes, for example. Right? Sometimes traffic generators go further. They might want to, they might be able to emulate stateful TCP connections, or maybe even go into the application payload, send real HTTP traffic, SIP traffic, and so on. One of the most important parts is, of course, measuring the result of this stress test, and that's where we need an ability to pull the state of the protocol, understand the metrics of the flows that transit the device under the test, to understand, how many packets were lost, what's the latency, and so on. Now, why people use traffic generator and where? The most mature and established use cases, of course, with people who build network products. Right? They want to control quality. They want to, align with protocol specifications. So over the years, this has been like 20 years journey, 20+ years journey. They build a lot of proprietary continuous integration pipelines internally that, then they use to achieve those goals. Now, when it comes to network operators, there are like two parts. The first part is when somebody is designing a network, right? You're preparing to build it. It's a very common task to use a traffic generator to decide, well, which components to choose, which perform better, which live up to the expectations. There is sometimes also use when people use traffic generator to just see, well, overall design, would it live up to the service level objectives that the business puts for the network? And then there is an even less established area where people use a traffic generator to validate the whole design. In fact, when I joined Ixia, which is now Keysight, like 6 years ago, I came from the network operations space, and I was really hoping now I'm going to know how to test a data center with much less time than I used to do it before it goes into production. But it wasn't the case, and it's not because the traffic generator lacks capabilities. It's more about there is maybe a framework, like well-established framework. How would you test a network with it? Somebody would have it, but it's proprietary, so it's not commonly shared, adopted, and so on. And that's important because if you go to the operating network, the use cases where we could use that traffic generator, but we don't, there are more and more of them because, for example, if you don't have a well framework to test the data center, for example, or some other network before it goes to production, you wouldn't be able to test it when you have like a change, when you're preparing a change. It's just too much work to create some framework at this point. So we think that there is a lot of opportunities here if we open up a way to communicate with a traffic generator in a way that it is public, vendor neutral, where community can contribute the use cases that they have, so that there could be workflows between those silos. There could be a workflow between the vendor and the network operator, and within the network operator between people who design networks and then people who maintain the network, so that they can use similar tools. Maybe tools would be different, but they could talk the same API, and that helps share the way you implement those tools, the way you use them. So let me go through a couple of areas we see the value here. So as I mentioned, the first one is the shared workflow between the vendor and the user. How the network operator tells to the vendor what kind of use cases they actually have, how they want to test the equipment if the whole test content is proprietary, right? We don't want to have this vendor lock-in. We want to be able to share such information freely. It becomes especially important if we are talking about not just commercial vendors, but open source NOS developers. You can have a open source developer who would like to write certain unit tests for the code he writes for its component, but of course, quite often is not able to afford or doesn't think it makes sense to bring up a commercial tool to test. And so, they use some open source testing toolkits that could be found. But then if you bring this open source project to the corporate user, they want to test at scale, right? They want to really make sure that this now can fit into their network on the same quality level as they typically expect from the commercial vendors. So it would be really nice to have the same test content that the original developer could use, and then the corporate network operator could run as well. Another area is integration with third parties. So let's say we have some network automation, network orchestration software developer who would like to enable certain validation capabilities provided by a traffic generator. Without open API, they have to integrate with each individual traffic generator one by one, which is frankly not feasible, and then it's hard to share it within community. And so if we have a common API, we make this job easier, and multiple people can contribute. And finally, the same thing goes to the use cases that go to the continuous integration for like change validation, data center validation, and so on, that people can freely share and publish as examples. With that, let's take a look at what it takes to create a public API for the traffic generator. So if you go back to this diagram, so we have these test ports. And those test ports would need to create those logical objects, routers, and endpoints that would generate traffic. So the first thing we need to do, we need to tell it what we want the traffic generator to create. So we need to define those objects. Once we do that, the second step is to tell the engine when to start a protocol, when to start the traffic, right? So it's the execution part. And then when the test is being executed, we look into analyzing results, getting metrics, making certain decisions about it. And so that kind of translates one-to-one to the Open Traffic Generator model. So the define part, it's the configuration that starts from a very basic things of like what's the settings on the physical port layer, and then like if you need to aggregate ports, what's the layer 3 configuration and so on, and ends up with configuring logical devices, protocols on them, and flows between them. The second part is the control, where you bring up interfaces, protocols, start traffic, so on. And then the third part is when you inquire state of protocols, like for example, did my BGP session came up? Did I get as many routes as I expected sort of installed? And then pull in the metrics about latency, counters, and so on. I was thinking how to present this OTG configuration to you. What it really is, it follows the Open API standard, which, I mean, it's a text file, it's YAML or JSON, or it's a protobuf, right? A description of the configuration. We have it published on the otg.dev website. I'm just using here a visual representation, right, to highlight the main components. So in the middle, we have device under the test. That's kind of not the part of the model itself. We have test ports connected to the DAT. And then behind test ports, we have emulated devices. We can have many of them, as many as we want, with different parameters like IPs and autonomous systems and so on. And then behind them, we expect to have like subnets that should talk to each other. And the traffic flows that we create between devices represent this traffic between the devices. We have several, so for this to happen, we need several components to align to the specification. The first part is the client part. This is something that you use to talk to the traffic generator and tell it what to do. Because OTG is an open API spec, it's really anything that can talk REST API or gRPC can be used as a client, like curl, it's just fine. But of course, as you're gonna develop, specific test cases, it helps to have a library. So for example, you can use Python or Go to quickly iterate through the Open Traffic Generator API without thinking about underlying API calls. So we have this library, it's called Snappy. And then finally, for those who just need to start somewhere and maybe don't want to go right into the developing the test program, like Python or Go program, there is a CLI tool that I'm going to show in the next few slides how to use it. That essentially implements the OTG API in a very, easy to use manner. So it's a good entry point. So we have a client. Now the client needs to talk to a server, and the server is the traffic generator itself. So by this moment, we already have several implementations of OTG API from different products. So the first one we built, it's called Ixia C. It's the containerized version of the Ixia traffic generator. It's not open source, but it has a free edition, or like community edition, right? So you can freely download it, launch it, use it. It's just limited in certain regard, but otherwise freely available. Then, as part of the OpenConfig, our friends there built Magna, which is an open source traffic generator. You can see actually how it's implemented, and it has like a pluggable architecture. It's sort of a skeleton so far, but it's made in a way that can be extended. So if somebody wants to add feature or maybe use that as an inspiration to build your own traffic generator, that's a good place to start. We also took on ourselves a task to see, like, can we take some open source project which doesn't comply to the OTG API and make like a proxy so that we can use it with OTG. So we took Cisco T-Rex project and created a plugin for it so that if you have an OTG test configuration, you can apply it to T-Rex and it will do its job. So you don't have to know how to use T-Rex really. So, and with that, if there are any developers of T-Rex here or somebody who knows them, we would love to continue this work and make this available with all the latest versions of both T-Rex as well as the OTG API. And then we have a commercial product that has all the capabilities. And then, of course, it's important to have test content. This is what's really lacking when we talk about just proprietary implementations. Nobody publishes example setups that deal with proprietary configurations and APIs. And here we can change that. So on the otg.dev website, we have examples. It's very easy to clone, reproduce, repeat, take a look how they work. In addition to that, OpenConfig project has a big library, a growing library of which is called feature profiles. That has a lot of examples how to test different capabilities of network devices, and you're going to hear more about that today. And then we have a couple of examples of contributions to Sonic ecosystem where we have some content there, written in OTG as well. Really quickly, how to use OTG API, I'll give you a couple of examples so that you can get a sense. So the very basic is when you don't emulate any logical devices, you just want to have traffic from one port to another port through your device under the test. We call it raw traffic. And I'm going to use this CLI utility to show how it really works. So the first thing you do is say, OTGen create flow, right? And the idea is when you run that and you give it parameters like what are the source IPs you want and the destination IPs and protocol and so on, it will create a description of the flow that traffic generator understands. It will be in the OTG format. It's essentially going to be a YAML file on the output of this command. All right? And I have a visual representation what it contains, but really it's just a text file. So you have that. What do you do next? You can now use OTGen run command to ingest that YAML file and apply it to a traffic generator. Okay? And when you apply it to the traffic generator, if there are no errors, you say start traffic. And then you pull metrics. And then you send the metrics to the output. So essentially, with these two commands, you can start traffic with random source and IP addresses, random protocols, whatever OTGen currently supports. And then you'll get immediately measurement results like this. And these are JSON strings that are being sent to the output. You can save them. They can analyze them somewhere, parse them. And we also provide a nice reporting utility that condenses all that to certain ways of representing it, like in a tabular format or graphs. Right? So this is just to get us first feel of what the traffic generator could do. Let's say if you have a more complicated example, you want to create two devices that would have a BGP stack on them and then exchange routes, and then that is going to be a traffic between those routes. So you do OTGen create device 2 times because you want 2 devices to talk to each other. You'll tell what the IP address of the device would be and at what port that device sits. So once you have that, you're going to add BGP stack to those devices. So it's essentially what happens here is this YAML file is getting more and more configuration added to it. You say, hey, I want to have this autonomous system over there, and I want a peer with an IP address of my dot, and then I'm going to announce this prefix over here. Once you have that, now you can create a flow between these 2 devices. Hope it's logical enough. But now what really happens, at the end, people start writing test programs because this is what you actually want to run as part of your CI pipeline to see if it fails or succeeds, right? And to give you a sense of what to use Snappy library, it follows these 3 steps. So to define configuration, you create a packet where you add Ethernet with MAC addresses, and then you say, hey, and then add IPv4 or IPv6 with IP addresses, and then let's add a transport protocol, right? So you just sort of create flow by flow what you need this way, and then once you have it, this is the configuration you can send to the traffic generator. You just say set config. If it accepts it, no errors in the response, you say, hey, transmit traffic, for example, if there is no protocols involved. If there are protocols involved, you start them first. And then when the traffic is running, you just pull statistics periodically and see how you're doing, right? Because we, have different people from community trying it, and we see where they fail. At this point, we sort of already aggregated some knowledge about the common pitfalls. I'd like to share a few of them. The biggest one is when people try to write a Python test program just using what they currently have on their laptop. And typically, there are broken dependencies. They don't know how to use virtual environment. It's all okay. It's really hard. You just start with a clean VM. You're going to save yourself a bunch of time, obviously. Then the other thing is when people start going after oh, this is my use case. This is the configuration I have in my network. You'll get there, right? But it will take time. Start with something very simple. The simplest thing you can do is don't have any device under test at all. Just connect two test ports back to back. Anything if you send from one port, it will end up on the other port for sure, right? So you eliminate a lot of broken things this way. You make sure your overall setup works, and then you can add the device under the test in the middle and start testing it. Okay, and also, it's a learning curve for some to start writing a Python program. So that's fine. We have a CLI tool you can use, so you don't have to necessarily start with programming. And also, we have a bunch of examples. As I said, you just clone the repository and execute those examples. It's a good way to get started. And the final one, when we build labs, not in hardware, but using software, containers, virtual machines, and so on, just try to use one of those declarative lab configurations, either Containerlab, Kubernetes network emulation. You're going to hear more about that today. Or at least use Docker Compose instead of just Docker Run. It's just much more repeatable that way. You eliminate a lot of errors. All right, so with that, I'd like to invite one of the OTG contributors, Markus Heinz from Google, who is representing the OpenConfig project.
Howdy, everybody. So I'm going to talk to you today just briefly on some specific use cases that we have been using OTG in Google testing. So in one of our main use cases that we really are interested in solving is having a network emulation that can emulate our various vendor types in a virtual environment. And so what we've actually built, and we're actually going to talk to y'all later today about KNE, is we have a Kubernetes-based network emulation platform, and we've worked in partnership with Keysight to add traffic and protocol generation into that ecosystem. And so in this scenario, as you see before you, this is just a simple system under test with a set of network devices that we bring up in our emulation environment. And as part of that ecosystem, we then attach the OTG ports to that to allow us to be able to do all of our protocol and route and traffic generation across those network devices. And then within OTG, it can actually then expand that topology to support virtual devices behind them. As I said, the routing protocols and the traffic then can be brought up and then forwarded across our network emulation. We can basically take something purely containerized and then develop a set of tests against that. And in OpenConfig, we've referenced the feature profiles repo that's there. That uses our Undatra test framework to drive a set of functional specifications that we have developed for our internal use cases, and we've open sourced. And the real benefit we're going for is being able to have an emulated environment that can bring up containerized network OSs and the protocol and traffic testing, and then develop a hardware test bed and basically take our tests directly from being able to be run in the containerized environment and then bring them to hardware. So thank you.
And please stay, if you can, to listen more about KNE and Andatra later at around 4 something. It's the time for that talk. All right, thank you, Marcus. And now in the final part of the presentation, what I'd like to explore with you is, like, how can you use this work and maybe try to apply it to your more daily work of operating a network, like testing something that goes into that network, okay? So, and as a simple example, I decided to take something very basic. What if you have to upgrade tonight to a new version of the network operating system, right? Do you know if it's going to work or not? Right? What does it take for you to figure it out? And it probably would be much easier if for every new version of the operating system that you care about, there would be an automated script that runs every time the version gets published, so that you know if certain things that it does, will it break or not, right? It would probably help. So let's take a look what does it take to create such an automated test setup. So we have some input criteria here. The one is the NOS from a vendor and what's kind of the model of that NOS and the version and so on. And then you have some service objectives. Right? You have a piece of the network where you need to have certain connectivity. So what does it translate to is that this NOS sits in a particular set of network segments. You can describe them and hopefully you can emulate them. Right? There is more and more possibilities now to instantiate a segment of your network using one of those software-based network emulators. And then the service objectives, they can be simple, like if my DNS server is reachable from everywhere, or like my SSH port is never reachable from the outside. Or they can be more complex. Like, for example, it depends like how much traffic I can push here, what the latency should be, although with network emulation, latency is not really a thing. But anyway, so once you have both, you can identify the network segment, and then you have criteria. What you can do, you can instantiate your CI pipeline with this network segment up and running and run the test script through it. So it would, bring up all necessary protocols and traffic and see if it's still performing as the objectives that you have, or would it fail. And I took an example that I have. So I had a lab that I built just for the sake of demonstrating how Open Traffic Generator works. And then I decided, well, okay, what if I try to apply this workflow if I upgrade versions of the NOS on the C or P routers. And in this lab, what I have, there are both FRRs, so that it's kind of easier for anyone to pull and run. What happens here, this setup is showing, it's a showcase for DDoS mitigation using RTBH. Okay, so we have an S-flow controller that gets information about flows that are flowing through the network, and if there is any flow that has a traffic rate above a certain threshold, considers that being a DDoS attack, and it installs a route on the ISP side that will black hole all this traffic, right? So the original app was designed to showcase that you can generate low rate traffic, high rate traffic, and then use that to demonstrate that the RTBH technique works. So now the FRR software that I'm using here, there was actually a breaking change in it like a couple of years ago. I knew about it. So I thought it would be nice if I can roll back this lab using the older version, make sure it works, and then one by one bump the version of the FRR to the point where the breaking change was introduced, and will I catch it? And so what I needed to add to the setup to enable that, it's just a make file in which when I run the CI pipeline using GitHub Actions, it's by the way a completely free way to run the CI if you have a GitHub repository. I instantiate this lab using Containerlab, and once it's up and running, I just run the test. Okay, so typically I would do that manually to show people how it works, but it's the same way you can do that in the CI pipeline. As you can see, there are, like in the table below, there are commits where I'm bumping the version of FRR from version to version, and when it gets to 7.4, where the breaking change was introduced, voila. Everything is breaking because actually no routes are being installed. I need to adjust configuration to follow more strict BGP implementation that FRR has starting from 7.4, and now I'm again good to go. Okay, simple example, but I thought to share it because it's publicly available. You can click on the link and see how to do it. So what I want to show, what I want to end with is a couple of references. So we have OTG.dev website, where you can find a description of the model. You can find links for the different implementations. We have a Slack channel. So if you're going to try one of the examples there or just want to try to do something, yeah, feel free, ask questions there. And hopefully that's all. And hopefully you can ask more questions here as well. Thank you.